Humanity has always looked to the heavens and wondered, searching for meaning in the stars above. For centuries, we've built instruments to help us see farther, to unlock the mysteries of the cosmos. The telescope brought the cosmos closer, but now we have something far more powerful. A time machine, the James Webb Space Telescope, or JWST, a marvel of modern engineering and human curiosity. JWST is the most ambitious and powerful space observatory ever built, designed to see the universe in infrared light, wavelengths our eyes cannot perceive. Its technology allows us to look deeper into space than ever before, peering through cosmic dust and gas that once hid the universe's earliest secrets. As the universe expands, light from the most distant objects stretches into infrared, making them invisible to ordinary telescopes. JWST is uniquely equipped to capture this ancient stretched light. JWST's golden mirror, over 6 meters wide, is tuned to capture this ancient glow. Its segmented design unfolds in space, creating a giant eye that can collect the faintest whispers from the dawn of time. It lets us peer back billions of years, to witness the universe as it was during the cosmic dawn, when the first stars and galaxies formed. JWST's mission is to illuminate the origins of everything we see today, to understand how galaxies assemble and evolve over cosmic time, how stars and planetary systems are born from swirling clouds of gas and dust, and to search for the building blocks of life on distant worlds, perhaps even signs of habitability beyond our solar system. Launched in 2021, JWST traveled over 1 million miles to the second Lagrange point L2, where it stays shielded from the sun and can cool to detect faint infrared signals. This remote outpost gives JWST a perfect stable view of the universe. From this vantage, JWST is revealing the universe's secrets, fundamentally changing our place in the cosmic story. Its discoveries are rewriting what we know about the cosmos. It is our silent sentinel, our eye on the infant universe, patiently watching and recording the birth of stars and galaxies. With every image, it brings us closer to answering the biggest questions about our origins, our place in the universe, and whether we are alone. The journey has only just begun, and the discoveries waiting for us may be more astonishing than we can imagine. Imagine pointing the James Webb Space Telescope at a seemingly empty patch of sky, a region so dark and unremarkable that it appears almost void of stars to the naked eye. Now, let it gather light for hours, patiently collecting the faintest whispers from the distant universe, photons that have traveled for billions of years. When the image finally returns, it's astonishing. Suddenly the darkness is filled with galaxies, each a sprawling city of stars, some relatively close, others so far away their light began its journey before our solar system even existed. In one such deep observation, astronomers spotted a faint reddish smudge, a tiny, ancient galaxy whose light has traveled over 13 billion years to reach us, carrying secrets from the dawn of time. Named CAPERS-LRD-z9, this galaxy is not just distant in space, but in time. Its light left when the universe was only about 700 million years old, a mere toddler on the cosmic timeline. Observing it is like looking at a photograph of a centenarian as a 5-year-old, a rare glimpse into the universe's earliest childhood. CAPERS-LRD-z9 offers a precious snapshot of the universe's formative years, during the mysterious epoch of reionization, when the first stars and galaxies were transforming the cosmos. Its Z9 refers to its redshift, a measure of how much the universe has expanded since the light left the galaxy, placing it among the most distant and ancient galaxies ever confirmed by astronomers. But the real surprise was hidden at its heart. JWST detected the unmistakable signature of something incredibly massive and bright lurking in the galaxy's core. Not a star, but matter being devoured by a supermassive black hole, the earliest, most distant one ever observed, shining with the energy of millions of suns. We weren't just seeing one of the first galaxies, we were witnessing one of the universe's first monsters, a cosmic giant feeding at the dawn of time, reshaping its surroundings. The discovery sent ripples through the astronomical community, sparking excitement and debate among scientists worldwide. It raised profound new questions about how such enormous black holes could form so quickly, and how galaxies and their central monsters grew together in the early universe. And it challenged everything we thought we knew about the origins of galaxies, forcing us to rethink our cosmic history and the incredible forces at play in the universe's first billion years. Black holes usually form from the collapse of massive stars, when their cores run out of fuel and gravity takes over, crushing matter into an infinitely dense point. But the one in CAPERS-LRD-z9 is different. A supermassive black hole, far more massive than anything a single star could create. JWST's data revealed it weighs 10 million times the mass of our Sun, an astonishing figure for such an early cosmic era. For comparison, the black hole at the center of our Milky Way is about 4 million solar masses, and it's considered enormous by galactic standards. And it had over 13 billion years to grow, slowly feeding on gas, dust, and even stars over cosmic time. Yet here, in a galaxy just 700 million years after the Big Bang, is a black hole more than twice as massive as the Milky Way's, existing when the universe was still in its infancy. It's like finding a fully grown adult in a nursery, surrounded by newborns. How could something so enormous form so quickly, defying everything we thought we knew about black hole growth? The black hole is actively feeding, surrounded by a superheated accretion disk that outshines its entire host galaxy, pouring out energy across the cosmos. The existence of such a massive black hole so early is a profound challenge to our models of cosmic evolution and black hole formation. A black hole born from a single star couldn't grow this big in so little time, even under the most extreme conditions we can imagine. This suggests something fundamental is missing from our theories, perhaps a new mechanism for rapid black hole growth, or a different kind of cosmic seed. Either black holes can grow much faster than we thought possible, or they start out much bigger, perhaps born from the direct collapse of massive clouds of primordial gas. CAPERS-LRD-z9's black hole is a cosmic puzzle, a mystery that challenges our understanding of the early universe. And it's forcing us to rethink how the universe's first giants formed, opening the door to new ideas about the origins of cosmic structure. How did this black hole get so big, so fast? The standard theory says black holes grow slowly, feeding on gas and merging with others over billions of years. But that doesn't work for the giant in CAPERS-LRD-z9. Maybe the early universe was denser, providing a buffet for black holes to feed rapidly. Yet, there's a physical limit, the Eddington limit, on how fast a black hole can grow before radiation pushes away incoming gas. This ancient black hole seems to be pushing or even breaking that limit. Scientists are exploring more exotic scenarios like direct collapse, a massive cloud of hydrogen collapsing straight into a black hole, skipping the star phase. Or perhaps dense star clusters in the early universe merged to form megastars that quickly collapsed into intermediate mass black holes. These dramatic pathways could explain the rapid growth. The discovery in CAPERS-LRD-z9 forces us to consider these violent origins. The early universe may have been far more chaotic than we imagined. CAPERS-LRD-z9 appears remarkably red, not just from cosmic redshift but because it's shrouded in thick gas and dust. This dust absorbs blue light from young stars, letting only redder light escape. The same gas and dust fueling the black hole also obscures the galaxy's starlight. We're seeing a galaxy in a chaotic, crucial phase, rich in the raw materials for both star formation and black hole growth. The presence of so much dust is a puzzle. Dust forms from heavy elements created in massive stars and released in supernovae. For CAPERS-LRD-z9 to be so dusty, it must have already experienced a burst of star formation and death. The early universe was a cosmic construction site, galaxies and black holes growing at a frantic pace. The red dusty veil is a clue to the intense, gas-rich environment that fostered the universe's first giants. It shows galaxy and black hole evolution are deeply intertwined from the very beginning. CAPERS-LRD-z9 is a window into that wild, formative era. Sometimes a discovery doesn't just add a new piece to the puzzle, it forces us to redesign the puzzle itself. The black hole in CAPERS-LRD-z9 challenges the long-held idea that small things form first and gradually build up. Its existence suggests the universe could also build enormous structures directly and quickly. It also forces us to rethink the relationship between galaxies and their black holes. Perhaps they grew up together, shaping each other from the start. If supermassive black holes formed this early, they may have played a much bigger role in shaping the universe than we ever imagined. These early giants might have been the architects of the first galaxies. Studying this distant black hole gives us a unique window into the epoch of reionization, when the first stars and black holes lit up the universe. Its light acts as a probe, passing through intergalactic space and revealing where the cosmic fog had cleared. By analyzing its spectrum, scientists can map the state of the early universe and learn what elements were present in its host galaxy. This tells us about the stars that had already lived and died, enriching the galaxy with heavy elements. It's cosmic archaeology, each photon a clue to our origins. This black hole is more than a record breaker, it's a Rosetta Stone for the early universe. It connects the physics of black holes with the evolution of galaxies and the cosmos itself. It anchors our theories with real data from a critical era. Every observation brings us closer to understanding how everything began. The story of our cosmic origins is written in this ancient light. The discovery of CAPERS-LRD-z9's black hole is just the beginning. JWST will search for more of these early giants. Are they rare or common in the young universe? By building a census, astronomers hope to understand how these black holes and their host galaxies evolved. The next goal: find the seed black holes, the direct collapse objects or remnants of the first stars. These will be faint and distant, pushing JWST to its limits. Long-term monitoring will reveal how these black holes grow and change. Each new observation adds detail to our picture of the cosmic dawn. The next few years promise a revolution in our understanding of the universe's first giants. The story of CAPERS-LRD-z9's black hole reminds us the universe is more surprising than we can imagine. Each discovery challenges our theories and expands our sense of wonder. The JWST is not just a tool, it's an extension of our curiosity, letting us witness the dawn of time. For every answer, new questions arise. We are explorers on an endless voyage, sailing the cosmic ocean. The universe's oldest secrets are finally being unveiled. The light from ancient galaxies is reaching us, carrying the story of our origins. Our grand adventure has only just begun.